So we started off with everybody seeing this, right? All right. Okay. Soraya, Caitlin, you all there?
Yeah.
All right. Nice. Good. So as I say, we'll try to keep this class short and quick, right? We started off with looking at a point and seeing that how we could translate using a translation. And that translation is a vector, right? And you can see how the vector is written in a column vector form. So whenever it's written in a column vector form, it means movement. So if it's written like this, it means that that is a point. But if it's written like this, it means that it is movement. You're moving 2 spaces horizontal and 4 spaces vertical. Right? I'm just doing a quick review of what we did last time. So if you have anything that you're unsure about, please feel free to interrupt me, right? So we saw that all we really needed to do was we'll put the point in the form of a vector and add the x's, add the y's, and we will get a prime, which we refer to as the image. Yeah, the image under the translation T. So you have to kind of get used to this language, right? So then we saw here now that, well, what if we don't have 1 point? What if we have 3 points, right? Or what if it's a polygon with 100 points, right? And we came and we translated each point separately over here to get the image, right? A prime, B prime, C prime, right? But we saw that we didn't have to translate each point separately. We could have actually just taken all of the points and put them in what we call a matrix, right? And basically we treating it like just the 3 vectors, treating it the same way. A matrix is just a different way of writing it. Instead of writing it in 3 different lines, we could put it all in a box. So we see here the introduction to the concept of what a matrix is. A matrix is just a way of representing large amounts of information. And now that we have this large amount of information inside of a box, we could operate on all the information one time instead of having to do it line by line like this. We could just literally operate on all of them one time and end up getting our image, right? So I hope everybody is okay with that so far. Shazay, I'm not hearing your mouth today. You eating or what? All right. Did you have lunch for the day? All right. What did you have for lunch, if you don't mind me asking? Roti? Roti and what?
Oh, it was like dal puri.
You eat dal puri by yourself? By itself? By itself?
No, I like eat a chicken roti.
Where you get chicken roti, Dread? Where?
Well, I think it was
Right, yes. Yeah, they started to do that now. It's a real sad condition this the place in, right? But thanks for getting me more hungry there. If it is that I do get angry, Shazay, I will make sure to take it out on you, right? So I hope you're understanding everything. So we saw here that a matrix is just a way of having large amounts of information, and we can operate on all of that information. So then we started to talk about, well, how do we operate on all of that information? And in order to get to do that, we have to understand what a matrix is. So we saw that a matrix is just a rectangular array of numbers or letters, blah, 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 with m rows and n columns, right? So the rows are this and the column is this, yeah? So just a little revision. We saw some different examples of matrices here with rows and columns, and we were able to identify how many rows and columns they have. And we saw that the number of rows and columns that a matrix has is known as the order of the matrix, where you put the rows first and the columns after, row by columns, right? So we can see the order of the matrix is seen as row by column, and you know, it helps us. It's important information. We can see that we use this order to help us with multiplication, determining if something can be multiplied, but we'll get to that just now. Then we were taking a look at the addition and subtraction of matrices, and we saw here that you just basically add your top line to the top line. You basically add your underneath line to the underneath line. When it comes to the addition and subtraction of matrices though, you will basically just have to deal with 2 by 2 matrices for your exam. They probably wouldn't give you anything harder than that. And we saw there that we just add the corresponding values. So the 5 will add to the 4, the 3 will add to the -2, this 2 here will add to the 1, and this 1 here will add to the 3. So we can see it here, right? That we just add those corresponding elements, and we will actually end up with our finished 2 by 2 matrix. And this is the same for addition and subtraction, right? We were actually doing some, did we do that yet? No, right? We spoke a little bit about identity, and we saw that the identity matrix for addition is the null matrix 0, 0, 0, 0. What does that mean? That means that if you take and dread, see, I underline this, make sure you know it, it's one of those things. It's one of those things that you will need to have on your fingertips, right? It'll help you with very complex questions, but essentially, if you take a number and you add it to the identity, you're supposed to get back the same number, right? So that plus 0 is that. So we saw here that the identity for addition and subtraction is 0, right? And the identity for multiplication and division is 1, right? So similarly, we spoke about the identity for addition of matrices to be that null matrix 0, 0, 0, 0. We still didn't speak about the identity for multiplication of matrices just yet, but we'll get to that today. And we tackled a very important question here, where we get to see that matrix addition is associative, right? Meaning that, you know, you could add them in different orders and you'll get the same answer. Did we conclude that matrix addition is commutative?
Yes.
Yes, thank you very much, Soraya. So yes, matrix addition is commutative as well, right? Then we saw multiplication by a scalar, means that you're just multiplying by a number outside of the brackets. And what do? Is you literally multiply that number by everybody. 2 times 3, 2 times -2, 2 times 4, 2 times 7. So 2 3s are 6, 2 2s are -4, 2 4s are 8, 7 2s are 14. You end up with your answer. Simple, easy, nice, breezy, and a lot of marks. A matrices question could be 11 to 15 marks depending on the paper. Then we spoke about this. This here is the part of matrices that has give everybody the most problems, right? And that is the multiplication of matrices, right? We saw that you can't just go multiplying any matrix. You had to look at the order. And the amount of columns in the first matrix has to be equal to the amount of rows in the second matrix. We also saw that there is a certain procedure that we have to use when multiplying matrices. That we take the first row and we multiply it by the first column, like this. Yeah, so A times E plus B times G. And that just gives us our first element, right? Then A times F. You notice how when I'm multiplying by the top, these two top elements here, give us these two top answers here. So A times F is AF plus B times F, so B times H, sorry, is BH. Yeah, you're multiplying by that there. So Shazay, are you okay with the multiplication of matrices?
Yes.
Alright, so we also saw a couple of things here. Not only is it that when you multiply matrices you have to look at the order, but also the order also tells you the matrix that you are going to end up getting at the end. So we could see here 3 by 2 being multiplied by a 2 by 4. So the number of columns is 2. The number of rows in this one is 2. So yes, they can be multiplied, but the outside number will actually give you the matrix that you will end up with as your answer. This is a really important point. Please note that point. We actually saw here, did some matrix multiplication examples where we saw that A cannot be multiplied by B. However, B can be multiplied by A. So that tells you that the multiplication of matrices is not necessarily commutative. Yeah. And then we did a couple of matrix multiplication questions, I believe, right? And then we started to talk about some other things, right? We started to talk about, but before we talk about these other things here, we will go through these things just now. But now that we're talking about matrix multiplication, guess what? I do have some questions for you here. All right? Okay, so I'm gonna give you guys 10 minutes and you have to multiply these matrices, right? There's a matrix multiplication question. However, remember that not all of them can be multiplied. So you have to work out if they can be multiplied or not. And if they cannot be multiplied, you can just put undefined as the answer. Alright? So I'll give you 10 minutes to work on these matrices here. So let me know if you all have any problems seeing this, right? And just these 6 questions, and you wouldn't have to do all 6 because some of them cannot be multiplied, right? So 10 minutes. It's so good, right? Anyways, let's get down to it. So we could see here, well, first let's check if they can be multiplied, right? So I have 2 rows and 2 columns here. So this is a 2 by 2. I have 2 rows and 2 columns here. This is another 2 by 2. So yes, they can be multiplied, right? We could see here that with a 2 by 2 and a 2 by 2, once these numbers are the same, then yes, they can be multiplied, and the answer we will get will be a 2 by 2 as well, right? So let's get down to business. So what do we have here? We are going to multiply this row by this column to get the first answer, right? So I'll take 0 by 6 is 0, right? Plus 2 3s are 6. So that first thing there, I got 0 plus 6, right? Now I'll take this row and multiply it by this column, right? So 0 times minus 6 is 0 plus, and then I'll take this 2 and multiply it by this 0, and that'll also be 0. And now I'll take this underneath column, row, multiply it by the first column, right? So negative 2 times 6, and I'll just put that there, negative 2 times 6, plus we have negative 5 times 3, negative 5 times 3. And now we'll take this underneath and multiply it by this second column, so negative 2 times negative 6, and then plus negative 5 times 0. So what do we get here for the answer? We get 0 plus 6 is 6, 0 plus 0 is 0. We have here 6, negative 2 times 6 is negative 12, right? Plus 5 trees as negative 15. So we have negative 12 minus 15 or plus negative 15. When the signs are the same, you add the numbers and you keep the sign. So down here we have negative 27. And on this side, well, this goes to 0. So what do we have here? 6 2s are positive 12. So yeah or nay?
Yeah.
Yeah.
No.
Alright, lovely. Now let's see if this could be multiplied. This here we have 2 rows, 1 column. So this is a 2 by 1. And in this case we have 1 row and 2 columns. So this is a 1 by 2. So yeah, they can be multiplied actually. Right? And we are supposed to get a 2 by 2. Right? Wait. 1 row, 2 columns. Yes. 2 rows, 1 column. Yes. Right? So let's see how this is going to operate. So I'm going to take this first row and multiply it by the first column. So 6 5s. So 6 times negative 5. Right? Then I'm going to take this first row and multiply it by the second column. So 6 times 4. Now I'm going to take the second row and multiply it by the first column, negative 3 times negative 5. And I'll take the second row and multiply it by the second column, which is negative 3 times 4. So you could see here that this is a 2 by 1, this is a 1 by 2, and the answer we'll get will be a 2 by 2. And you can see how this works out to be a 2 by 2. Now, I'll have to tell you the truth. At the beginning, I was kind of confused at this one. I was like, oh, this is kind of odd, you know. But it was only when I wrote out this, the orders, then I could see that they could be multiplied. Not only that, but I saw what answer to expect. Because just by looking at it alone, you can't really expect, you know, you can't really see what kind of answer you'll get in terms of a matrix, right? But you can see that I wrote out the order and I saw that I should get a 2 by 2 matrix, and I did. Right? So what do I have here? 6 5s are negative 30. 6 4s are 24. 5 3s are positive 15. And 4 3s are negative 12. Yeah or nay?
Yeah.
No.
Alright, so what you do wrong, Squisher? You what? You added them because you saw that it had to add. You just normally add them, right? Yeah. But you just normally add them because you have this one and this one, so you had to multiply this by this and then add it to this by this, eh? Right. But you see there, I didn't have that in this case. In this row and in this column, I only had one number in each, eh? Yeah, so it didn't have anything to add. So you saw here, Scotia, that in terms of not getting confused, I just followed the procedure. This row by this column first, and I see that it didn't have anything to add there. So yes, all right, that's okay. So we can see this is another 2 by 2 and a 2 by 2. So yes, we could tell that they could be multiplied, and chances are for CSEC, you'll get one of these, right? So first row by first column, and I'm just gonna go it through fast, right? So 5 times 2 is positive 10 plus 5 times 3 is negative 15, right? So that is the first set there. Now I'll do the next set. 5 3s are positive 15 plus 5 5s are negative 25. So Scotia, you understand what I did there?
Yeah.
Alright, so you don't need me to write out all of the things. Okay. So you let me know if you get confused about any. And you understand this last one here, right, Scotia?
Number 2?
Yeah.
Yeah.
Alright, good. Nice. So now I'll do the bottom row. Negative 1 times negative 2 is positive 2 plus 2 times 3 is 6. And then negative 1 times negative 3 is positive 3. And then 2 times 5 plus 5 2s are 10. So what will I end up here with? I'll end up with 10 minus 15 is minus 5. Negative 5. This here, 15 plus negative 25, that is negative 10. 6, 7, 8, 10, 11, 12, 13. Yeah or nay?
Yeah.
Oh, what did Shazay do wrong here? Let me hear you, Shazay.
I've mixed up on the signs.
You mix up the signs. So you did the multiplication correct. Is in here is where you got the wrong thing?
I mixed up the sign, but the first 10 plus negative. I had 25 because I had it as 10 plus 15.
Oh, 10 plus 15. So you didn't see that this and this was positive, right?
Yeah.
Alright, so okay, alright. But you understand everything I did here though, right?
Yes, sir.
Alright, lovely. Number 4. Yes, this is another 2 by 2 and 2 by 2, so I can see they can be multiplied. So I have here 3 times 6 3s are negative 18, and then 5 times 1, so that's plus 5. Right? And now these for the second column, negative 3 times negative 2 is positive 6. And 5 times 5 is negative 25 plus negative 25. For the underneath row now, negative 2 times 6 is negative 12, and 1 times 1 is 1. And here negative 2 times negative 2 is positive 4, and 1 times negative 5 is minus 5. So what do we have here? Negative 18 plus 5 is negative 13. 6 plus 25, I believe, is negative 19. Correct me if I'm wrong. Negative 12 plus 1 is negative 11. And 4 minus 5 is negative 1. How all you feel about this?
Yeah. Yeah.
Yeah.
Alright, good. You sure, Shazzy? That yeah sound a little bit suspicious. Alright, okay. So let's see. I wonder if these could be multiplied, right? So this here is 1, 2, 3 rows by 2 columns. And this here is 1, 2. Oh, yes, they can be multiplied by 2. Right? And the answer I'm supposed to get is a 3 by 2. Right? So they can be multiplied absolutely. So let's see. I thought one of the beginning ones was supposed to be undefined, you know, but so far everything.
No. So all of them we have to be looking for.
Yeah, sorry about that. I thought at least 2 was undefined because I did this already, right? So we have this top multiplied by this. So let's do that multiplication first. And I'm supposed to end up with a 3 by 2. So let's see how that works, right? So this top is 0 times negative 4, which is 0, plus 5 times negative 2 is negative 10. Alright? Now I'll multiply this top by this guy here on this side here. So I'll have 0 by 4, 0, plus 5 times negative 4. 5 4s are 20, negative 20. Right? Then we have here the second row. So negative 3 times 4. So I'm multiplying the second row by the first column now. Right? Negative 3 times negative 4. 4 3s are 12, positive 12. Plus 1 times negative 2 is negative 2. And now this row by the second column. So negative 3 times 4, positive 4 now. That gives us negative 12. Plus 1 times negative 4 is negative 4. Now the last row, 5 4s are 20, plus negative 2. And then we have 5 4s are negative 20 this time, plus negative 4. And if I make any mistakes, please let me know, because I'm starting to just kind of rush it on. And when you start to rush down matrices, Dread, matrices easier. But you see like the mistake that Shazay make? When you start to rush things down, that is what has happened, is negatives that is get to you, and all of them kind of thing, right? So we see here that we have negative 10, we have negative 20, 12 minus 2 is positive 10, negative 12 minus 4 is negative 16, this is positive 18, and this here is negative 24, yeah or nay?
Yeah.
I hear 2 years there, 2 outstanding. Shazay?
Yeah.
Shazay?
No, I was trying to find it because I didn't work in kind of all over the place and I didn't have the questions.
Shazay, and I buffed you the other day about making clear statements something?
Yes, sir.
And you see how, you know, it have a clear progression from here to here?
Yes, sir.
Shazay, and you know I didn't eat today?
Yes.
Alright. So let's just see. I'm guessing here, alright, so we have 2 rows and 3 columns. And in this case here, we have 3 columns and 2 rows. So yes, they can be multiplied, and we should get a 2 by 2 matrix at the end. Right? So let's see. Alright, so I'll take this first row and multiply it by this first column. Right? So 5 4s are 20. Right? And I'm going to add that to 3 3s and negative 9. And I'm going to add that again to 5 3s are positive 50. Yeah. Now I'll do 5 times 2, that gives us 10. I'm going to add that to 4 times 3, 4 3s are 12. I'm going to add that to 5 5s are negative 25. Now the bottom row, 1 4 is negative 4.
So is on the first 20 supposed to be a negative 20?
Yeah, actually. 5 4s are 20. Yes, thank you very much. Thank you very much. Right? I didn't eat them, so you know your brain does need food, right? 5 3s are negative 15. Right? And I could have, let me just put the plus there just in case anybody having problems understanding, right? 5 times 3 is negative 15 plus 0 times 3 is 0. And you know, some people just put 0 times 3 is 3, yeah? I almost do that, yo. I almost do that. That's it, I have my brain working right now. Now the second column, 1 times 2 is 2 plus 5 4s are 20 plus 0 times negative 5 is 0. So So you see I did end up with a 2 by 2 matrix. And what do I get? Negative 29 plus 15 is negative 14 over here. What do I have here? 10 and 12 is 22. 22 minus 25 is negative 3, is it? Over here, negative 4 and negative 15 is negative 19. And over here, we have positive 22. Yeah or nay?
Yeah.
Okay, what you do wrong? You didn't add all 3 of them. Right, because you didn't know you had to add all 3 of them. Hello?
I don't know. I just started really confused. I don't even know where to start.
Well, the first place you start is by writing the order and checking, right? Yeah? And you notice how I just followed the procedure, right? The first thing I did was I write the order. This is a 2 by 3. And this is a 3 by 2. So I saw that they can be multiplied, and I saw what the answer was going to be. Right? So I know what to expect. And then the next step was to follow the procedure. I take this row and I multiply it by this column. Right? So when you're taking this row and you multiply it by this column, you're multiplying one element by the corresponding element, and you add them. You understand, Scotia?
Yeah.
Are you still confused by it, or do you understand it? Alright, I hope so. Alright, so seeing that you guys do understand, can these two be multiplied? I'm not asking you to multiply them, but can they be multiplied? Alright, I have 2 no's. So we can see here, this is 2 by 3, and this here is also a 2 by 3, and those numbers are not equal, so these cannot be multiplied, right? Nice. Last question. Of course, you know I had to give you one of these. You have 1 minute.
What?
1 minute. Alright, 1 minute is up. We could tell it's a 2 by 2 and a 2 by 2, so yes, they can be multiplied. So let's do this row by this column first. So we can see I have negative 4 times negative 4x. So that is positive 16x. Right, plus negative y times 2y will give us negative 2y squared. Yeah. Then we'll have negative 4 times 0 giving us 0. And negative y times negative 5 gives us positive 5y. Then over here we have negative 2x times this negative 4x. 4 2s are 8, so that's positive 8x squared plus negative 4 times 2y. 4 2s are minus 8y. Okay. Then finally, we're going to end up with this and this. So negative 2x times 0 is 0, plus 5 4s are positive 20. So the answer here, that cannot really be simplified, is 16x minus 2y squared. On this side I have 5y. Over here I have 8x squared minus 8y. And over here I have 20. Yeah or nay?
Yeah. I wasn't done, but I was getting there, so basically.
Alright. Shazay?
I didn't get that.
Okay, how come? What did you do wrong?
I just get mixed up between the y squared and the
Oh. Do you understand what I did? Alright. Okay, nice. So let's just continue with the rest of it and finish off this topic of matrices here. Right? So we were dealing with matrix multiplication, and we got some nice little practice with matrix multiplication just now. Right? And now we started to talk, and we did talk about these guys last week, so this is more revision, right? We started to talk about the determinant of a matrix. And you'll only ever have to find the determinant of a 2 by 2 matrix, right? They'll only ever ask you that. And the determinant of a matrix is given by that modular sign there. And as I was saying, you know, when we had vectors, right, and the modular sign meant Pythagoras theorem, and it meant the length of the vector. And a vector was only a 2 by 1 matrix. That is what a vector is, right? Just a 2 rows, 1 column, right? But when we're dealing with a 2 by 2 matrix, we call it the determinant. And it's not really a length, it's more of an area, right? It's more of an area, yeah? So, if we check in terms of what the determinant is, right? Remember this first guy here is A and C. So I have the point AC. So that'll be A on the x-axis and C on the y-axis. And that is the point AC, right? And then I have BD. So I'm gonna have B here and D here, what we call it there. So that is point BD. And look at what I have. I have A times D. So A times D is this area here, minus B times C, which is that larger area there. So you can see that the determinant has something to do with area. However, you are not required to know the area thing, right? I just basically, because all I did was Scotia, you know, it's because of Scotia that I put that on all it. Because Scotia does always be asking, so what's that? How you just use that? What that is for? So it does almost sound like that though. So no, you don't sound like that, right? So at the end of the day, I just wanted to show you that the determinant has something to do with area, but you're not really required to understand what. You're just required to work it out. And this is just a simple formula. Determinant of a matrix is that, right? So I believe you had to do these two for homework, did you?
Yeah.
All right. So let's just see. And you can see here, all you have to do is multiply this diagonal and minus it from the multiplication of that diagonal. And that's it. All right. So let's see here. B modulus of B, that is what? A times D, which is negative 2 times negative 3, minus 5 times 1. Alright, so what do we have? We have negative 2 3s are 6, right? Minus 5, which is 1. And in this one here, we have 4 3s, so the determinant of C, 4 3s are 12, right? And we're gonna minus, right? 6 2s are 12. Oh my goodness, right? Negative 6, and you know. So let me actually write that better, because that minus sign might confuse you all. So let me write it out. 4 times 3, right? This, that is AD, minusing this, negative 2 times negative 6. So we can see, you can see here how the brackets just make it a lot clearer. So we can see here that we have 12 minus 6 2s are 12. Alright? So whenever you in doubt about negative signs and things, use brackets. Brackets just help you. We see that is 0. Now, what do we call a matrix that has a determinant of 0? And that doesn't seem like much, but it is one of those things that you should remember. Yeah? they will actually ask you something pertaining to the singular matrix. And you have to remember, you go see singular matrix. Where's that, boy? What do you expect me to do there, boy? But this is all we know about a singular matrix. So when you see the word singular matrix, know that, well, the determinant is equal to 0. Right? So guess what? They might have, and I'll see if I could find a question like this for you guys for next class, right? Because I think I've seen a question like this before. They might have 4x here, and they might have 2x here. And then they go tell you, you know, the matrix C is a singular matrix. Find x. So you could be like, what? The matrix C is a singular matrix. Find x? How I find an x? But you should know that singular matrix means that the determinant is 0, which means that you do this multiplication, right? And that'll be what? 4 3s are 12x minus, well, blah blah blah, and then you'll end up get 0 here, right? And then you could throw across things and solve for x. So that is one of the questions that they could ask you, and I'll see if I could find a question like that in the next class. So you see all of these tiny little things like singular matrix and the identity thing, all of these tiny little things you make sure you have in your mind, right? No, not that yet. Right. So after we looked at determinant, we looked at the adjoint matrix. Where did you go? No, not there. Here we go. We looked at the adjoint matrix. And the adjoint matrix is really, really important. And we'll see why it's important just now. Okay? And in the adjoint matrix, all that we really did was we switched this diagonal. So instead of AD, we now have DA. We keep the other diagonal how it was, but we put negative signs in front of it. So B adjoint is equal to, we flip this diagonal, so the -3 gonna here, and the -2 will be here. And then we put negative signs on the other diagonal. So this will be -5 and -1. And that is B adjoint. Right? C adjoint is, I flip these two, so I'll put the 3 here and the 4 here, and then I put negative signs. So negative in front of -2 will give me a +2, and a negative in front of -6 will give me +6. And that is C adjoint. Yeah or nay?
Yeah.
So see?
Mm.
Nay? What you do wrong? You understand? You want me to explain it one more time?
Well, I get the second one correct, but sorry, no, I get the third one correct, but the second one.
You notice that all I did with this diagonal here, all I did was flip it, you know. I didn't mess with the signs or anything. You understand?
Yeah.
All I do was flip it. That is all. No messing with no signs, no adding, no subtracting, nothing. Just flip it. Right? And as the other two, you don't flip it. You leave them there, but you put negatives in front of them. You understand? Alright? So this here, literally this. You flip that and you put negatives in front of that. Right? So you're okay, Shazay, right?
Yes.
Alright? I hope so, because you're going to need to be okay with adjoint and determinant of the matrix in order for us to carry on with this next section here. This next section here is the inverse of a non-singular matrix. You notice I have the word non-singular underlined, right? The inverse of a matrix. So just like how you have a vector, like let me just say the vector 2, 4. And that vector 2, 4 will carry you 2 spaces there and 4 spaces up. right, to give you this here, the vector 2, 4. But what if you wanted to go the other way, right? Well, you find the inverse of the vector, which is just really minus in. I mean, you're really just going -4 spaces now and -2 spaces now, right? So you can see here that the inverse of a vector is actually pretty easy. You just put a negative sign in front of it. But when you're dealing with a matrix now and you have 10 vectors in the same bracket, you can't just go and put a negative sign in front of all of them. Yeah? So when it comes to matrices, to find the inverse of a matrix, we have a special formula. So you can see here, and you notice non-singular, and I'll ask you that question just now. Why non-singular? Why can't I find the inverse of a singular matrix? Right? So I hope that somebody could answer that question just now. Right? So if I have a matrix A, B, C, D, then A inverse is equal to 1 over the determinant multiplied by the adjoint. Right? Scotia, what is A inverse? Yeah, Scotia, be careful. A inverse is 1 over the determinant multiplied by A adjoint. So I am going to do this first one. You guys write down this formula and say done it when you're done so that we can start to do a couple questions. Right, nice. So A inverse, so I have the matrix A here. A is equal to 1, or sorry, A inverse. I get the formula wrong. I'm now buffing Scotia. I get the formula wrong. Right? So A inverse is equal to 1 all over the determinant of A multiplied by A adjoint. Right? So A inverse is equal, and this is the one I'm working on right now, A, right? Is 1 all over the determinant. So where's the determinant? I take these two, 4 3s are 12, and I minus these two, 1, 2 is 2. Okay? And be careful with negative signs and things. Be careful when you're doing that determinant. Right? This minus here will mess you up if the other number is negative. Because if this ended up being -2, it would have been 12 minus -2, which is 12 plus 2. So be careful with those signs. Right? Multiply by the adjoint. So the adjoint is I'm going to flip this first diagonal here. So I'm going to have 4 and 3 over here. And then I'm going to put negatives here, -1 and -2. That is all. Right? So what do I have here? 1 over 10 into 4, 3, -1, -2. And that is the answer. That is all. Right? You have the 1 over the determinant multiply by the adjoint. And remember, if you want, this is a scalar. 1 over the determinant is a scalar. Multiply by that. So if you want, you can multiply it out and it'll get 4 over 10, -2 over 10, -1 over 10, and then 3 over 10. And you can see here that is only that -2 over 10 could simplify, or the 4 over 10 could simplify as well. Right? So the final answer. And you could have leave it so, You could have leave it so, no problem. No problem, you could have leave it so, right? But if you wanted to go through the horrors, and sometimes you do have to go through the horrors, yeah? If the question asks you, right? So 4 into 10, 2 over 5. And then this one here is -1 over 5. And then this one here is -1 over 10. And this here is 3 over 10. And that is the final answer. Say done it when you're done. So, B inverse is 1 all over the determinant of B multiply by B adjoint. Alright, so 1 all over the determinant of B is 2 times 3, and the negatives will give me a positive 6, minus 5 ones are 5. Alright, multiply by B adjoint, which is a flipping these two, so the negative 3 here, the negative 2 here, and then I put in negative 5 and negative 1 over here. So what do I have now? I have 1 all over 6 minus 5 is 1, multiply by that. Well, you know that that is just simply negative 3, negative 1, negative 5, negative 2. Yeah or nay?
Yeah.
Alright, what did you get for C? The answer for C. Well, the answer for C is undefined. Why is it undefined? Anybody want to tell me?
I'm assuming because we're supposed to put the negatives where it is negative.
No, not at all. If you're putting the negatives in front of here, then they'll just become positive. But you know. How did you get 0?
I got 0 because it was both of them are 12, so 12 minus 12 is 0, so multiply by the thing is 15.
So the determinant of C is 0. That's what you're saying?
Yeah.
Right. So if the determinant of C is 0, right? And that's what we got up here. We worked out the determinant of C here, right? The same matrix. Determinant of Z is 0. 12 minus 12, right? So therefore, C inverse will be 1 all over the determinant of C multiplied by the adjoint. The problem is, adjoint is I, yeah. The problem is that this works out to be 1 over 0, right? So C is a singular matrix. Remember that? Right? A matrix with a determinant of 0 is a singular matrix. Look at here. The inverse of a non-singular matrix. So you cannot have an inverse of a singular matrix. Because a singular matrix, the determinant is end up being 0. Well, 1 divided by 0. And 1 divided by 0 is actually not 0, eh? Right? So when you said the answer was 0, that was not correct. 1 divided by 0 is not 0. 1 divided by 0 is undefined. This here, 1 divided by 0, that is one of the greatest unknown mysteries in mathematics. Yeah? Nobody knows the answer for what is 1 divided by 0. Nobody knows the answer for that. Yeah? So we call it undefined, right? Okay, next topic. We're almost done. But these next 2 topics are actually going to be the harder topics, right? And these topics are going to use what we already know, right? So what they say in here, and this is a real important thing, right? Is that given you have A, the matrix A, which is this, the identity for matrix multiplication, is 1, 0, 0, 1. Right? Now, when it comes to multiplication, And what we were talking about here on this side is this is the identity for matrix addition. So we know that if you take any number and you add it to the identity for addition, you just get back that number. Similarly, this here is the identity for matrix multiplication. So if you take a number 2, multiply it by the identity for multiplication, which is 1. Remember, the identity for addition is 0, but the identity for multiplication is 1. You'll get back 2. Okay. So this here is really important. But when it comes to multiplication, we have another really important thing. If I take a number and I multiply that number by its inverse or its reciprocal, right, then I will get the identity. This here is a super important rule. If I take a number and I multiply it by its own inverse or its own reciprocal, I will get the identity. Similarly, and I wonder if anybody could actually do this, right? Similarly, if I take a matrix and multiply it by its inverse, or I take an inverse and multiply it by its matrix, I will also get the identity, which is this. Okay? And if you want over here, you could put the identity for multiplication being 1, 0, 0, 1. So write down everything here. Don't write down this, but write down everything here and let me see done it.
So you told us to write that down last class?
Yes, and we didn't really look at it, right? But now I have a hell of a question for you all. A hell of a question for you. Alright? Done it? Alright, nice. So this question is, and I don't know if I could do this question, right? Now this rule, highlight it, underline it, all kind of thing, because you're going to need that rule, right? You're going to need this rule. Now what we're about to do here is on the CSEC syllabus. They will never ask you this in an exam, so if you get it wrong, don't worry. If you feel stupid and you can't do it, don't worry. They'll never ask you this in an exam. But of course, I just like to take you to the next level, right? So the rule is that if I have a matrix A, and this is the matrix A, B, C, D. And if I take the matrix A and multiply it by the inverse of A, right? Prove that A multiplied by A inverse equals the identity, which is 1, 0, 0, 1. So you have to know, and I'll give you 3 minutes, right? You have to take this matrix and then you have to find the inverse. So you have to find A inverse. And then you have to multiply both of them. And you're supposed to get this. You'll notice something, and this is a little piece of headache here that I'm going to save you from, or I should have saved you from, but I don't know if you went through the headache, right? I have A multiplied by the A inverse, right? So I have A, B, C, D. Multiply by this A inverse here. But you see this determinant? I'm not going to multiply that determinant throughout, No. I'm gonna leave that determinant out for a minute. So I'm gonna leave the determinant in front here. And then over here, I'm gonna multiply my A by my A inverse, by the adjoint, sorry. So you see here that I did not take the determinant and multiply it. I just kind of left it on the outside, and I'll do that multiplication after. Right? So let's deal with those, those matrices first. Right? I have the first matrix there. This column by this row by this column gives me AD plus B times minus C is minus BC. Right? So that's the first one. This row by this column now, A times minus B is minus AB, and then I have plus AB, B times A. Now I have this underneath row by the first column, CD right, plus minus CD, and then I have this underneath one multiplied by this one here. C times B is minus CB, right, and then plus AD. So what am I going to get here? 1 all over AD minus BC. And you can see that this here is AD minus BC. This one here is actually worked out to be 0. This one here is worked out to be 0. Kitty, do not walk on the computer, please. And this here works out to be AD minus BC as well. You notice what's going on there. So now I could multiply my determinant throughout. If I multiply this by this, I'll get 1, 0, 0. If I multiply this by this, I'll get 1. Scotia, how you feel about it? Right. Did you multiply this determinant here first, or did you leave it out? Oh, yes, yes. So you would have catch real stress. You would have get the same answer, you know. You would have get the same answer, but you would have catch real stress. Shazay, how you feel about it? All right. Now, again, you'll never get this in exam. Don't worry. Well, not the proof anyway. The proof, you would never get it in an exam. It is in the curriculum though. However, you see the law, we just proved this law. That if you take a matrix and you multiply it by its inverse, you will get the identity. We need this law. So give this a quick write down and let me hear 4 donuts. Simultaneous equations. Oh no, we all know how you all love simultaneous equations. And I saying that like if I share the screen, and I did not share the screen. Boom! Simultaneous equations, right? So for the simultaneous equations, solving a matrix solving simultaneous equations using matrices. Remember when we did simultaneous equations, we did lots of methods there. The first method we saw was when we did coordinate geometry and we had 2 lines intersecting. The point at which they intersect was actually the solution for the simultaneous equation. So it had the graphical method, then it had the method of elimination, which we kind of ignored, because we went to the method of substitution, which is even the most useful method, right? But this here, this method, totally different. Totally, right? You could see that I have my two simultaneous equations here. Very important. Look, I put the x's together and I put the y's together. Please make a note of that. Please make a note of that. Your x's should be together there and your y's should be. So if it's not together, rearrange the equation so that they are together. Right? So once you have it like this, where the x's are one column and the y's have a column, you can actually take the coefficient for -5, 3, and 2 and form a matrix. And look, the x's in this column and the y's are in this column. And what we say is we say that this matrix multiplied by xy is going to give us this matrix, which is the answer -6, 7. So Scotia, you're okay with how to form the matrices from a simultaneous equation?
Yeah.
Shazay, you okay with it? Right. And now we use this procedure. Right? Imagine this. I have, and don't write down this, these are a little scribble here, just for me to remember, so that I would not teach all your nonsense, right? But procedure. And I go write it over. I'll just put it on this side. Right? The procedure, right? Number 1, you put it in this form. This is of the form A x equals b, where you have this matrix A multiplying by this matrix X to give you this matrix B. You understand that? Shazay, okay? Right. So number 2, multiply both sides by A inverse. So you could see here that when I multiply A inverse times AX is equal to BA inverse times B. I'll multiply both sides by A inverse. Right? That means you know the rule. The rule is A times A inverse is I. Right? So therefore the A's will kind of cancel off here. You'll just get I. I multiplied by anything is itself. You could think about I as 1. So essentially what we did was we got rid of the matrix from this side. And that is A inverse times B. Right? And once you work out what A inverse times B is, you will have your answer. Right? So let's just do this this example here, and then we'll call it quits for today. Right? So the first thing I have to do is find A inverse. A inverse is 1 over the determinant. 4 2's are 8 minus, and 3 times 5 is -15. So you notice how that could have messed you up there. You use your brackets. 5 times 3 is -15. We'll have a -5 there. And right. So you can see here that the determinant is actually 8 plus 15. 1 all over 8 plus 15. And actually, let me write it a little bit different. The determinant of 8. 1 all over 8 plus 15. which is 8 plus 15. It's 23. 1 on 23. Right. Actually, no, that's not the determinant. Sorry, the determinant is 23. Sorry, my bad. Right? Let me just do that over. The determinant of A. Oh, why? Oh, all right. The determinant of A 4 times 2. I'll do it a little easier. Minus 3 times negative 5. And that is 4 2s are 8 minus negative 15, which is positive 23. So we find the determinant of A. We find A adjoint, which is simply flipping the 4 and the 2. So 2 go be here, 4 go be here, and I put in negatives on the others. So this will be negative 3. And when I put a negative in front of the negative 5, I'll get positive 5. That is A adjoint. Therefore, A inverse is 1 all over the determinant multiplied by A adjoint. Everybody cool so far? Yeah. So I find A inverse, recall, right? A times X is equal to B. Therefore, X is equal to A inverse times B. Why? Because of this rule. You could also think about it like if you're throwing over the A. Because you know, if you had 2x is equal to 6, when you throw over the 2, it has become x is equal to 6 multiplied by 1 over 2. So this is the inverse of 2, isn't it? Yeah? So you could think about it like throwing over the A. Right? So now x is what? xy, and xy is equal to the inverse 1 over 23 all over by 2, 5, negative 3, 4 multiply by the matrix B, which is just simply negative 6 and 7. Right? I'll leave the determinant on the outside and I'll multiply my matrix first, right? And I'll put this over on this side here. And I'll actually put these in a different color. Let me actually just reduce the size of this because I like that a little bit too big. I could do all of this, you can't do this. Right. So you can see there that it wasn't really too much of an issue, you know. All I needed to do was find A inverse, and now I'm multiplying the inverse of A by this matrix here, that's all. Right? So what do I get? I get xy is equal. Now, you imagine this is a 2 by 2 and this is a 2 by 1. So the answer you get is going to end up be a 2 by 1. Right? So I'm going to leave the 1 over 23 outside and I'm going to make my multiplication. I'm taking this and I'm multiplying it by this. So 2 6 2s are negative 12. Right? And then 5 7 5s are 35. So plus 35. Right? Scotia, you understand how I do that multiplication there, right?
Yeah.
Alright. And now I'll multiply the underneath row there. 3 6 3s are 18. That's positive 18. And then 7 4s are 28. Alright. So now what do I get? I get, I'll just bring this over on this side here. So this implies that xy is equal to 1 over 23 multiplied by 35 minus 12. The matrix is 20. Ooh, look, 23. And then 18 plus 28 is 46. Right? And now you can multiply your determinant. So you multiply your matrix first. Don't multiply by the determinant yet. Leave that outside. Multiply by the determinant last. So therefore, xy is equal to, I'm multiplying out. So when I multiply 1 over 23 times 23, I'll get 1. And when I multiply 1 over 23 by 46, I'll get 2. And look, you have your answer. Therefore, x is equal to 1 and y is equal to 2. So, to recap what we just did there, and when you learn how to do this properly, you actually could solve a simultaneous equation quicker this way. Right? It's a very quick process once you know what you're doing. So firstly is we have the equations here and we put them into matrix form. Make sure your x's are in one column, your y's are in one column. We multiply that by xy and we put the answers in another matrix here. Then we apply the rule. The rule here is that, well, okay, if a times x is b, then I could just throw over the a. So x is equal to the a inverse times b. That's all this here. That's all you really had to remember. Okay? So you'll see that in order to find x, I just need to find the a inverse. So I found the determinant of a to be 23 and the adjoint. And therefore a inverse was this. And all I did was to recall that to find x, which is the matrix xy, that's what you're looking for, the matrix xy, which is x, right? To find x, I just have to take the inverse and multiply it by that matrix b. That is all. Yeah? You leave your determinant outside, you multiply your matrices, and you will end up getting a 2 by 1 matrix. And when you actually work it out, you'll actually get x and y. Scotia, how you feel about it?
Okay.
So you understand everything that I just did, the full procedure?
Yeah.
Yeah. It's not really that much, you know. All you really had to remember is this. X is equal to the inverse of a times b. And of course, you have to know this because that is where this comes from. This comes from this. Right? So you have to put it of the form axb, which isn't really that tough. Once you put it in the form axb, you'll have the matrix A, so you find the matrix A inverse. Right? The matrix A comes from the coefficients of the equation, x and y. So the matrix A comes from all of the coefficients. You find A inverse, and once you multiply A inverse by B, you'll actually end up getting the answer. Shazay, how you feel about it? Remember these matrices here came from this equation. So I hope that you all got these equations too, right? Yeah?
Yeah.
Shazay? Now Shazay, I want you to notice the statements. Right? I didn't just go and do a set of work and blah blah blah. I made the statement A inverse. Is that so that the examiner, no, not A inverse, sorry, A determinant is that. So the examiner could clearly see, well, okay, he finds the determinant first, and then he finds the adjoint, and now he finds the inverse. Right? And watch how easy it is for an examiner to correct this. So the examiner just looking through and be like, all right, well, yeah. Okay, recall. You notice the statements I'm making. I'm not just going to start multiplying matrices just so. I'm making the statements first. So the examiner go see, okay, that's what he doing. All right, cool. He's gonna do this, and look at doing it here. X is equal to A inverse times B. Well, look at do it here. So the examiner will see that. Say, all right, cool, 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 correct. Watch how quick an examiner could correct this, because you made appropriate statements. You tell it like a story. Yeah? If it is you just put a set of working all over the place, you're gonna give the examiner real hell, and the examiner is not going to want to give you marks. Right? So please, Shazay, everything that you're doing, Shazay and Soraya, because Soraya, you guilty of this as well, eh? Shazay and Soraya, and well, Scotia, well, everybody, you know what? I'm buffing everybody because I'm hungry, so I'm gonna eat. But before I eat, I'm gonna give you all a couple of questions here to do for homework. So please write down these questions and then we'll go, right?